for this example, we want to find the center, transverse axis, vertices, foci, and asymptotes of the following hyperbola, and then we want to sketch a graph. So the first thing we need to do is get this equation into standard form. So the first thing I would do is group together the x terms and the y terms and move the constant to the right side. So we get 25x squared minus 400x minus y squared minus 2y is equal to negative 974. Now, because we have a 25 in front of the x squared, we need to factor it out of all of the terms containing x. So we have 25 times x squared minus 16x, and I'm going to leave a space here because I know I'm going to be adding a number. From the y terms, I need to factor out that negative, so I have negative y squared plus 2y, again I'm going to leave a space because I know I have to add a number, is equal to negative 974. Alright, now we need to figure out what are those special numbers that we need to add to both the x terms and the y terms. So the way we do this is we look at the coefficient of the linear term, so we would be looking at 16 and 2. We want to divide those numbers by 2 and then square them. So 16 divided by 2 is equal to 8, and 8 squared is equal to 64. So we're going to add a 64 to the x terms, and for the y terms we have 2 divided by 2 is equal to 1, and 1 squared is equal to 1. So we're going to add a 1 to the y terms. Now we need to figure out what we need to add to the right side. So because we have a 25 sitting outside of the x terms, even though we added a 64 inside of the parentheses, because we have that 25 outside, we're actually adding 25 times 64. So to the other side, we need to add 25 times 64, which is 1600. Alright, same thing goes for the y terms. Because we have a negative sitting outside of the parentheses, even though we're adding a 1 inside the parentheses, we're actually adding a negative 1 since we have that sitting outside. So to the right side, I'm also going to add a negative 1. Okay, so now we just need to simplify and factor. So we'll have 25, and if we factor down the x terms, we'll get x minus 8 squared minus y plus 1 quantity squared. And if we add everything together on the right side, you should get 625. Okay, so the last thing we need to do to get this in standard form is just to divide every single term by 625. So our final standard form will be x minus 8 quantity squared over 25 minus y plus 1 quantity squared over 625 is equal to 1. Okay, so now that we have this equation in standard form, we can find out all we need to know about it. So first, let's find the center. So the center will come from those numbers that are being added and subtracted from x and y. Okay, so our center here is going to be 8, negative 1. So remember that you get the coordinates by switching the signs on x and y. So our center is 8, negative 1. At this point, I would start drawing a picture so you can kind of see what it's going to look like. So let's put some axes down here. So we have x, we have y, and your center is at 8, negative 1. So we need to go 8 units to the, we'll just say that that's 8. So we go 8 units to the right and down 1. So our center is going to be about right there. Now we need to decide how big our central box is going to be. So notice from your equation that the number under the x term is 25. So that means our box is going to be 5 units wide from the center in either direction. So 5 units to the left of 8 will give us 3, and 5 units to the right of 8 will give us 13. So we have our box 10 units wide, and for the y direction, the square root of 625 is 25. So 25 units up from the 0.81 will give us 24 on the y-axis, so we'll have the 0.824. And going in the negative y direction, we'll have negative 26. So we'll have another point at 8, negative 26. All right, so these 4 points form our central box. And let's go ahead and dot that in. Okay, so there's our central box, and we can also draw our asymptotes. So asymptotes connect the corners of your box through the center. So one of the asymptotes might look like this. And the other does the same thing in the other direction. So those are our two asymptotes. So now let's see what else we need to find. Well, we need to find the transverse axis, and the transverse axis is that axis along which the hyperbola is oriented. So notice that this is going to be a horizontal hyperbola because the x term is positive. So this is going to be horizontal. So our vertices are going to be these points on the left and right sides of the box. Okay, so the transverse axis is that line that connects the two vertices and the center. So the transverse axis is going to be the line y is equal to negative 1. Okay, the vertices, like I said, are going to be the points on the left and right sides of the box. So from our picture, we have the point 3, negative 1, and also the point 13, negative 1. Let's go ahead and maybe draw in the shape of our hyperbola here. So we've got the two branches going from the vertex to each asymptote, and remember it approaches the asymptote, but it never actually gets there, so be careful when you're drawing that. So this is what our hyperbola looks like. Okay, so we need to find the foci next. So remember, for the foci, you need that distance c, which is the distance between your center and your foci. So let's see, for a hyperbola, we have that c squared is equal to a squared plus b squared. A is 5 and b is 25. So we have c squared is equal to 25 plus 625, which gives us 650. So c is equal to the square root of 650, which if we simplify that radical, we get 5 square roots of 26. So this is approximately 25.495. So when you're drawing this on your picture, you might want to kind of guess. So roughly 25 units to the left of 8 will give us something about 17 units in the negative direction. So this might be your first focus. And your second focus would be the same in the positive direction. So it might be somewhere over here. It's going to be pretty far out because this is a pretty wide hyperbola. So this might be focus 2. So all we need to do now is just figure out what these points actually are. So focus 1, or actually, let's just do the foci in general. So your foci here are going to be your center plus or minus that c value in the x direction. because notice this is a horizontal hyperbola, so your foci are moving in that x direction out from the center. So we have our center x coordinate is 8. We want to both add and subtract 5 square roots of 26, and our y coordinate is still -1. Okay, so those are your foci, and the last thing we need to do is just figure out the asymptotes. So there are some formulas for this. What I like to do though is just to figure it out from the picture. I think that that's a little easier. So first of all, figure out what the shared point is between your two asymptotes. Okay, and this will always actually be the center. So the center is along both asymptotes. So for our point slope form, our point is going to be that center. So we're going to use the point 8, -1. So all we need to do now is figure out our slope. And this is really easy to get from the box. So if you start at the center and think about your most basic definition of slope, which is rise over run, to get to the corner of the box, we go up 25 units and over 5 units. So up 25, so our slope is going to be 25 plus or minus 25 over 5, which is just plus or minus 5. Okay, so we can write the equation of our asymptotes now because we have a point and a slope. So in point slope form, we have y plus 1 is equal to plus or minus 5 times x minus 8. And so getting your equation of your asymptotes is just as easy as that. And I think that that is all we had to do for this problem. So center, transverse axis, vertices, foci, and asymptotes. And we also got our picture in the process.